So in this lesson, we're going to talk about rational functions, just our day one. A rational function is any function that can be written in this form, where it's a function with the n of x, where that is a polynomial, over d of x, where d of x is also a polynomial, so a polynomial over a polynomial, but that d of x cannot equal 0 because we can't have 0 in the denominator spot. So parent function f of x equals 1 over x would look like this, just to kind of give you a guide. So we are going to talk about some parts. I'm going to give you a little quarter sheet that will help you kind of keep things organized as you are working through these. But we have what's called asymptotes, and that is the boundary lines that a graph of a rational function approaches. And the vertical would be x equals kind of that dashed vertical line. So to find the VA, vertical asymptotes, you're going to set denominator equal to 0 and solve. Because remember, it can never be equal to 0. That's why it is this line that kind of approaches that. So it's what makes the bottom 0 for the expression kind of after canceling. Okay. Horizontal is going to be your y equals, and so that's going to be again, horizontal dashed line. And we are going to have our polynomial over our polynomial. We're going to look at the degree. So the largest exponent on the variable. So we can have three options here. We could have a degree that's equal. So this one is squared, this one is squared, and so those would be equal. So it's going to be y equals the leading coefficient of the numerator over the leading coefficient of the denominator. And so for this example, our leading coefficient here is 1, and then on the bottom it is 3, so it would be 1 over 3, or 1/3. Then we could have where the larger degree is on the bottom, and so 2, and that one's 1. And so when the numerator is less than the denominator, then it is y equals 0, or just the x-axis. And then we could have if the larger degree is on the top. So if the numerator is greater than the denominator, then we have none. The domain, we're just going to set the denominator equal to 0. And then holes are going to be a break in the graph. What factors match on the numerator and denominator? We set those equal to 0 and solve, and that is going to get you your hole. So an omitted point on the graph formed by having those same factors is what a hole is. All right, so let's go ahead and take a look at this first graph here. This has a degree of 1. That also has a degree of 1. So that means When the degrees are equal, we use the leading coefficients of the numerator over the denominator for our horizontal asymptote. So because those degrees are the same, we're going to use our coefficients. So it is just going to be that y equals 1. So for this wholes, remember we look for common factors, and there are none. X minus 2 is not x. So there are no common factors of the same exact set of parentheses on the top and the bottom. For the vertical asymptotes, we are going to set the denominator equal to 0. So x equals 0. There's no other solving that has to take place on that one. All right, so let's go ahead and graph this, and then we'll do our domain. So I'm going to draw my horizontal through 1 on the y-axis. So here's y-axis, here's 1. I'm going to draw my vertical through 0, which is just the y-axis itself. It's hard to kind of even see that. And then we're just going to kind of draw our curves. And you can type this into your graph to kind of look to see where those curves are going to be. So let's go ahead and jump to our Desmos, and I'll show you. So all I did was just start typing parenthesis, clear it out, parenthesis, or again, you can use this keypad down here, parenthesis, and then x minus 2, close parenthesis, and then divided by x. And there it is. So you know kind of where it should be at. So our domain is going to be setting the denominator equal to 0. So we are going to be going from negative infinity to 0. So that x equals 0. And then from 0 to positive infinity. All right, so let's take a look at this next one. So wholes, remember, are what they have in common. So common factors, and we do have one right here. So we're going to set that equal to 0. And then x is going to equal negative 3. That's a whole. So these cancel each other out, and we're left with f of x equals x plus 2 over x plus 1. So now we're going to go ahead and do our vertical and horizontal asymptotes from our simplified, after we've simplified there. So we have the same degree, or you can start here by setting your denominator equal to 0 if you want to jump to that one. So x plus 1 equals 0, so x is equal to negative 1. We look at our degrees, and we have the same degree. And so we're going to use the coefficients. We'll kind of put it down here. Degrees are equal, and so it is going to be 1 over 1. Or 1. And then again, my vertical asymptote was the x plus 1 equal to 0. And then my whole was the x plus 3 equal to 0. And then my domain is setting that denominator equal to 0, and that's what we're going to was negative 1, so it's going to be from negative infinity to negative 1, and from negative 1 to infinity, positive infinity. So let's go ahead and type this one into Desmos. It was x plus 2 over x plus 1. And there it is. So we're going to make our graph look like that. After we let's put in our asymptotes first. So vertical is going to go through -1. Horizontal is going to go through y equals 1. And then our graph. So go ahead and try number 3 on your own, and then push play to check when you're ready. All right, so here are your answers. I forgot to show you the whole, we forgot to graph that on our graph in number 2. So I'm going to jump back up here real quick, and we're going to plot our whole, which was at -3. So I'm going to go -1, 2, 3, and here's my graph. So I'm going to go ahead and put kind of an open circle for my whole on number 2. So back down here to number 3, a whole is where the top and the bottom have common factors. So x plus 1, and then I solve. And here's my whole at -1. And then I now have the f of x equaling 1 over x minus 4 is what I'm really looking at. So this degree is 0. This degree is 1. So when I am looking at the numerator is less than the denominator, it's y equals 0 for my horizontal asymptote. My vertical, I'm setting that denominator equal to 0. I'm getting 4. And so then that 4 is in my domain, -infinity to 4, and then 4 to positive infinity. So we're kind of pausing at 4 there. So graphing the horizontal axis here, your horizontal asymptote kind of along that x-axis, and then through +4 is the vertical. And then we graphed it. Don't forget your whole right there at -1.